Well, welcome to Rob's Fix-It Shop. Today I've got on my bench a heater. I don't need to fix it because it works, but so I've got this problem. I've got chickens, and in the winter here, it's Minnesota, it can get pretty cold, right? And the chickens do well even in very cold, but I just feel kind of guilty when it gets like below 0 Fahrenheit, right? And so oftentimes if it's going to be below 0, then I'll turn on this heater on their chicken coop. And their chicken coop's maybe, 6 by 10, and it's got an 8-foot ceiling. And then that just warms it up a little bit. But the problem is then I leave it on, and then this thing just stays on all the time, right? Because it's meant to heat a house, right? So when it says temperature max or whatever, I don't think you can really turn it in a way that, yeah. So really what I want is I want the ability to turn on around 0 degrees and just keep it at a low temperature, or even 10 degrees would be fine, right? Because it doesn't that often get, below, it usually doesn't stay below 10 very long, right? And it's indoors or it's inside the chicken coop, so it's not like it has to work that hard. But so what I did is I bought this temperature controller here with a solid state relay and a probe for temperature. And what I'm going to do, I'll clean it up first because it's been in the chicken coop. It's not the best place to be if you want to stay clean, but I'm going to clean it up, and then I'm going to get rid of all the current temperature controls on it, and I want to put this, and then I can just set the temperature at some low temperature and then set it and forget it, right? And then then when the temperature comes above 10 degrees or whatever I pick, this thing shuts off, right? Because I'm really irresponsible about going out there and shutting it off, which is fine for the chickens. They like it, but I don't know. And you can even keep it above freezing if you don't want your eggs to freeze, right? Because sometimes when it's really cold, the eggs will freeze and kind of wreck them. So anyways, if you're interested in that, I think it'll be mildly interesting, and sit back and enjoy. Yeah, it looks like I might have to work on this cord a little bit too. Looks like I just did the old electrical tape job on it, but yeah, I'll put a new cord in it as well. Oh, the cord's bad down here too. Okay, so I got it cleaned up, and I've just plugged it in and turned it on full. And looks like we're drawing about 1300 watts and a little over 11 amps. So good information. So I'm going to shut that off so it doesn't get hot. Okay, so here's the kit I bought. So here's the temperature controller. It's a PID control, which means that it doesn't just get below a certain temperature and turn on full and overshoot and fall back and overshoot and fall back. It actually tries to smooth the curve and kind of pulse the electricity going into the heating elements so that it smooths that out and maintains a decent temperature control. And you can kind of see it's got some descriptions of that here. Right here you can see the PID control kind of zooming in on a temperature. But you definitely want PID control when you're using these. And the thing to remember is that it's not just turning on full and shutting off. It's actually has a pulse width modulation, meaning it's kind of pulsing. It's turning on and off over a second. Here, let me draw that out for you. So what it's doing is it's so as you have, like, let's say you're at this temperature and you want to be at this temperature. Well, here you want to put a lot of work into getting up here, right? But as you get close, you want to start leveling off, and so that you don't overshoot by much, and you kind of manage that leveling off. And so what it's going to be doing here is it's going to be almost full on. So it's going to have, usually these have like a 1 second duty cycle, so it's going to be on almost the whole time like this, right? But as it gets up here, and when it's really close, it's going to be turning on just for a short amount of time and just maintaining that temperature, right? So it's going to be running more continuously than it does with this thermostat, where the thermostat just overshoots, shuts off, undershoots, turns on, right? And so this is a much nicer way to do temperature control. I mean, for a chicken coop, I don't know. The most important thing to me is that I can set the temperature low, where most regular traditional thermostats, you can't go below like 50 degrees. So, but that's kind of the theory, I guess. PID controls are super interesting if you ever want to learn about them and how these work. But so we've got the temperature controller, we've got a solid state relay, right? Came with a cooling fin. I don't know if we'll need that. And then it's got a temperature probe, right? And so really what we want to do is, I mean, these heaters are pretty much just a giant resistor, right? And you put 120 volts through it, and it gets hot, right? And so right now the way this works, for the most part, is you have a thermostat that, you know, turns this, lets the current through, right? And then when it gets hot, this opens up, or it gets hot enough, it opens up, and you know, and so what we're going to do is we're going to put this temperature controller in here, and actually we're going to do it like this. We're going to put this solid state relay here, and we're going to hook the temperature controller to it like this, right? And then this solid state relay is going to control the high current through here, and this guy's just going to output 5 volt pulse width modulated. The other thing too is there's probably some kind of a safety switch in here for tipping. I don't know. I'm assuming there is, so we'll have to keep that as well. But yeah, so all we're really doing is replacing that thermostat with a nicer, essentially, thermostat. So let's get going and see if we can open this thing up. It's not that light either. Yeah, look, this cord is just completely... Yeah, check out this cord. I can't believe it even worked. We'll have to change that. Put something heavier duty in this. I mean, it's almost like I'm making a joke, but a chicken coop is actually kind of a harsh environment. Okay. Ugh, gross. Okay, gross. There's a bunch of chicken gross stuff in there. Okay, I'll be back. I gotta wash this all off. Okay, so here's I kind of looked at the circuit, and so on our hotline, we're coming into the thermostat, and then we're coming right into the 2 heating coils. So there's 2 heating coils, one that's got a higher resistance and one that's got a lower resistance. So the lower resistance one is the high, and and then on the other side you have the power coming in, and you've got a heat fuse here, and then you come over here into the switch, and the switch turns the on light on, but it also switches between either the high resistance, which is low, medium resistance, which is medium. Wait a minute. The high resistance, which is low, the lower resistance, which is medium, and then I think it puts them both in parallel, maybe? I don't know. Must be parallel for high. So they're both cooking on high. And then with the heat fuse, if the heat fuse goes out, then the current's going to flow through here, around here, and through the caution light. So the caution light is only going to come on if the heat fuse goes off, and there's no tip detector in here at all. So here's our, if we trace it through, our power comes in, it comes up to the thermostat, and the thermostat then goes right back to the common of the heating element. And the heating element has an element here and an element here, and the two of them, the two ends are just connected here. And so that's so that the thermostat is just controlling that simple up and around. But then as we come in the other side, we come to here, we come into the heat fuse, we come out of the heat fuse up into the switch here, and then we have two wires, the white and the blue. And the white and the blue are coming to the one heating element or the other or both. And the switch also turns on the light. So that switch is doing quite a bit there. So I think what I'm going to do is I'm not going to mess with any of that. I'm going to leave the high, medium, and low and not worry about it. And because they'll all work, right? It's just, we're going to just switch out the thermostat, and we're going to replace it with this guy. And so we're going to, I think we can keep it kind of simple. So all we've got to do is we've got this is, I don't think it'll fit like that. It might. It might fit right in the end like that. That would be kind of good, except that in a chicken coop, all the shit flows down, right? So I think I'm going to put it right in here, right? And then we can set the temperature on the side, but turn it on and off from the front. A little weird, but I think that'll work. Yeah, so I just got to figure out how to cut a hole in here, and I think that's the next step. Okay, let's see if this fits in here. Oh yeah. Okay, so now we have to mount the temperature sensor, and it looks like it's just a probe at the end. And so I think I'm just going to drill a hole through here and stick it out the side here, and then we'll just find a nut to go on there. And then these two deals here, they just connect right into the temperature sensor. And well, the other thing too is we have to get AC power to this guy too. Okay, so I was wrong about something before. The on light actually comes before the thermostat, and so we should be able to power our controller right off the same circuit as the on light. Then we can use our little rotary dial to turn it on without, I was kind of looking at using a switch like that, but yeah, so I think if we use the same power that's going to the on light to power the controller, I think we'll be good. So the on light comes right here and then comes back to here. So I think if we just cut these and add something to go to here, I think we're going to be cool. Okay, so let's do that. And the controller only takes a small amount of power, so we don't have to worry about some big wire for it or anything. Do. Okay, we'll crimp these. Okay, and then okay. Now, okay. All right. So I added a ground wire, got the connectors all in. So now when I plug it in, our temperature control should, see what am I, I'm on, off. So when I turn that, it should be off, and then when I turn it, it should go on. We'll see. Okay. Nothing, that's good. And then turn it. All right, so it looks like currently we're at 73 degrees. Where's our temperature probe? Okay, you see how it's going down when I'm warming it up? So I'm warming it up and the temperature is going down. That means that the thermocouple is hooked up backwards. So let's switch that. Okay, so let's try it again. So our temperature is going up, right? So here I can even yep, this is working great. Okay, so now we just have to mount our temperature, our solid state relay, wherever that went. This is really getting to be a mess here. And it comes with that big heat spreader, but I think I'm going to try mounting it to here and I'll see how hot it gets. If it gets too hot, then I'll have to figure that out, but I don't think it will. Okay, now I got to hook these up. And okay, so that's in there. And now we just have to, I don't know what to do here. I should just redo this one because this has to come all the way to here. Okay, so now we should have our heating element completely hooked up through here, should have power going to this, which we saw. And let's feed this guy in through here. A little nerve-wracking with all that extra wire that's got. And that comes through here. Okay, so now I think we just have to get the wires between here and this to turn this guy on. And that should be, and plus is 3, minus is 4. So plus. Okay, now I'll put a little thingy over it. And let's plug it in, see if it works. Okay, so our current temperature is Okay, so far we're good. We've got our power light is on. This, of course, makes no difference. First of all, let's see if it's going on. So, because we're targeting 221 degrees, which is too hot. And so here I have the temperature set to 67. Current temperature is 66. And here you can see it's just kind of pulsing it. And that, every time the light goes on, means that we're putting heat into the heating element there. So, yeah, so I think it's working. So I think I'm going to button it up, and we'll try it in some real world conditions. I think I've got a bit of a problem in that one of the digits is out on the controller, so I don't know, but okay. It's just one of those things, I guess. Okay, well, I have it all back together, and have it on high, and I just have it warming the room. I have it set for 72, and it came from about 66, and now it's kind of overshooting. And you can see that it's just barely going on or whatever. But you should see it kind of settle down to this temperature. And that light means that the coil is engaged, and now the light is completely off because it's like, oh, I'm too high. Yeah, this is a big room too. Okay, a couple of fun things before I wrap up. So if I flip this on, right, and I've got it set to 80 right now, kind of bugs me that segment's out, but I bought this. Yeah, whatever. I don't care. Whatever. It's for a chicken coop, but seems like kind of a quality issue. But I have it set at 80 right now, and so it's currently on. And I have it on high, so I have it going to the top element. And we can see that we're using about 11 amps through that. And so these SSRs, the solid state relays, they produce about 1 watt per amp. So that's about 11 watts. That's probably enough to dissipate the heat through, because I'm mounted right here, right? But, I don't know, it's not too bad. It's going to be used in a cold environment, but they do ship with these things here, these heat sinks, and you just put some thermal paste on here and put it behind the controller. And if you're going above, I don't know, I think I might even retrofit it and put that back in. But if you're going above 10 amps, you should definitely have some heat sinking on there, because you're getting around 14 watts or whatever. That's a lot of heat for that chunk of metal. So the other thing I wanted to show you is, remember when I talked about PID earlier? These controllers use PID control to get the temperature right. And if the PID is off, what happens is the heat, cycles too much, right? Where if the PID is correct, it'll be able to just like pulse and hold it right at the temperature, and it'll be able to pick the right amount of energy to put into the coils to match the heat loss that's happening. And so that these controllers have an auto tuning procedure. And it doesn't do me much good to auto tune here, because I'm in my lab, I'm in the house, it's spring, you're not going to get a lot of heat loss. But out in a chicken coop, I want this thing working when it's 20 degrees, right? And or below. And I want it to be working efficiently in that kind of an environment. And so the PID that you pick for that, where you've got a lot of heat loss, is a lot different than you would pick for here. So for me to do the auto tuning, and what auto tuning does is it runs, well here, let's look at what it does. So what auto tuning is going to do is it's going to take your set temperature, or SV as they call it, right? And it's going to it's going to drive the temperature up until it crosses that threshold, and then it's going to see how long it takes to fall down below it. Then it's going to heat above it. It's going to let it fall below it. And it just depends on the auto tuning algorithm that they use, how many times they do this. But what they'll do then is they'll pick the P, I, and D parameters based on how that works, right? And so how fast you have to drive the heat of building up from, -5 degrees to 20 degrees is a lot different than like in my lab, right? So it doesn't make sense to auto tune it here. So really what I need to do is wait until the temperature is cold, bring it out to the chicken coop, and so here's the service manual for the manual for the temperature controller. And here it's just showing how to set the temperature. You just push set, then go up or down. But then, so auto tune, we're going to set it to the set temperature that we want to be ideal. And we're going to come down here then. Here, let me see if I can get this a little bigger. So for auto tuning, we want to hold the down air. We want to get to the temperature that we want it auto tuned at. So we pick our ideal temperature, and then we hold the down arrow for 5 seconds, and then it's going to sit there and auto tune. Okay, so PV is going to be blinking, and then it'll stop, right? But yeah, so that's how you do the auto tune. So get it to the temperature you want to auto tune at, hold it for 5 seconds, and then it'll take a little while, right? Depending on the environment, right? Like if you've got a big room or a temperature that is close to the outside temperature, then it's going to take a while to kind of do this auto tuning. Because like I said, it has to kind of come up and then come up to the temperature and then fall down below it, come up and fall below it. And then from that, it's going to pick its PID values. You're not going to want to try to pick the PID values by yourself, although most controllers allow you to set them directly, but you can get into all kinds of oscillations like that. So I'm going to do a couple of upgrades on this, and then I'm going to be right back, and then we're going to wrap up. Okay, so here's the 2 upgrades I'm going to do. I have decided that I'm going to take this, because it did get warm through the tin. I'm going to take this and I'm going to mount it to here, and then I'm going to mount it to the side here. So that'll be more than we ever need for that. And like I say, I don't think we necessarily need it for being out, in the cold, but why not? Safety first. Okay, so I'm going to attach this instead right over here, and then we'll mount that to here. Everything still fits perfect. That'll be better, I think. Okay, that's a little fancier, huh? And then, all right. Actually, I like that better. So, okay, so we got our heatsink all connected to our solid state relay. Next thing is to, I didn't like this here, the temperature sensor here. It's too close to the body, and so it's picking up all the heat coming off here. So I just want to take this out, and I want to be able to, when I put it out in the coop, I just want to put this temperature sensor where I want the temperature to be right. And once I do that, then that's when I'll do the auto tuning, right? And because it doesn't do me any good to have the auto tuning when it's so close to the heat source itself. All right, so an interesting thing. So now you see this segments here working. So I bought this controller like 6 months ago, and I didn't discover that the segment was bad until I started to do this video. So I was able to take the controller apart, and these are all surface mount LEDs, and this particular one was not properly connected on one side, so I resoldered it. Looks good. My advice, if you get a bad segment, return it, get another one. It did seem like the circuitry inside was pretty nice. But, well, that's it for Rob's Fix-It Shop Temperature Control Edition. The same sort of thing that you're doing here with this heater. I mean, I've got a chicken coop, I want to keep it warm, but there's a lot of temperature control things that somebody like you or me might want to control. This is a really nice way to do it. It's not very expensive, and you can actually switch quite a lot of current on it. You got to be a little bit careful about the wiring for that high current stuff. Like I say, that solid state relay does produce about 1 watt per amp, and that can be kind of one of those things can melt if you're like switching a lot of current on them. So yeah, you might want to use the heat sink. Other than that, I think it went pretty well. If you're interested in this controller, I'll put a link where I got it on Amazon below. If you're interested, I don't know. I did have to do that repair on it, but I should have just returned it. It would have been easy to get another one. And yeah, so I don't know. Hopefully that'll make my chickens happy. I think it'll make me happy because I'm not wasting a bunch of energy heating it when I don't need to. And if you liked the video, please hit like and subscribe, and thanks for watching.